Hello. I hope I'm start losing a voice this morning. I hope it will last till the end of the presentation. Otherwise, we're going to do some sign language or subtitles on the screen. Anyway, my name is Jovan Strika. I'm representing MikroTik. MikroTik is bringing enterprise features to MikroTik router boards. We designed the enterprise-grade enclosure. It's a desktop rack or wall-mountable. Has a integrated single or dual power supply, and we added a UPS and the battery as well. And then there are a few other options. We do the 3GLT integrated or the application board, like a Raspberry Pi or some other small board computer in the same chassis. And then we added also some of the cloud services using MikroTik scripting language, and it talks to our API and provides some nice features such as network monitoring and management from the cloud. Today, I'm going to talk about web filter and how we can add a filtering using the public DNS service. I'm going to start with a very basic about how DNS works. I know most of you are expert in that. Will be a boring part, but I'll segue then to Anycast and how Anycast helps the DNS. Then we'll talk about OpenDNS and what kind of capability they brought as a public DNS provider, especially about the classification of the internet, and then how you can use it with the MikroTik boards. And I'm going to finish up with the advantages and disadvantages of using public DNS providers. So if we look at the very basic diagram, we have a user connected to their local network with a router, and that's facing the internet with a couple of public servers. So when you have a user requesting the website, they want to go to our Macrotick.com, request is sent to the router. In this particular case, we have a router, MikroTik router installed with a DNS server. Now, unlike many other routers where they just forward the packets, they can be presented as a DNS server for the local users. They don't necessarily have a DNS server explicitly installed on them, where with the router OS, you can actually enable DNS server, which will keep the records and keep the cache locally. So in the case if you're requesting the website, it will be a lightning fast response if there is already a record in the memory, what is the IP address of the website. But in this case, there is no cache, so router will then try to resolve that URL, and it will send the request to there's a kind of multiple DNS server starting from root to dot, then goes to the com, and then domain name, name server for the domain name, which usually you set up when you register domain, and then finally to the DNS server that holds the records and resolves the www.macrotik.com to the IP address. And then that response gets sent back to the browser, which then will contact the web server using the IP address. So that's a very basic fundamentals of kind of how DNS works. So when we look at a slightly different scenario, in this case, router is not actually hosting DNS server. So request will then, in that case, be sent to a public DNS server, which will be provided by the local DHCP server. So when the client tries to send a request, it will be sent in this case to let's say Google DNS server 8.8.8.8, and then that one, for example, in this scenario has the information local in the cache, responds that back, and the browser will contact the web server. So when we look at this scenario, this is we're all probably using the public DNS server, and there is nothing really new about it. But the question came very often is, okay, what's happening if and response time with the public servers, how fast they will be able to reply on my request. So there is a couple of things involved in this. One is the a time to get to the DNS server from Google, and then the second thing is how fast that infrastructure will reply back. And very often, a perception is If something is DNS server is closer, like from your ISP provider, it will be faster. But with a lot of tests that we did, we see that public DNS servers are responding actually much faster than some of the local ISP servers, just because of the infrastructure that they put it in place. So when you talk about it, that's a response time. What about travel time to the DNS server and back? For that, we try to kind of zoom in into this internet cloud and look at how that looks like. So when the router is trying to get to the Google DNS, it actually goes through multiple hops, multiple routers that are in between, and that's what really defines the internet, the set of routers talking between themselves using the BGP protocol. That BGP protocol exchanges the routing information between all these routers. Each of them knows how they can get to different AS numbers or group of IPs, and then they automatically choose the closest path how to get to destination. So in this case, it's kind of green line, a shortest path to get to that DNS server. And if that fails, then it will reroute using the line above, its additional hop, but that's actually what creates the resiliency of the internet and automatic failover, which is completely transparent for the users as well as the router, how that information came back. So again, I know I'm repeating some of the maybe basics, but it was important to be able to look at the following scenario where the Google DNS, which is 8888, in earlier case was located in US. There is also DNS server with the same IP address presented, let's say, in a UK location and advertised within the routers that are in that area. What is happening in this case is it's using the BGP protocol to sort of leverage some of the functionality, which is advertising, and routers are not really aware where that 888 is located. They just look at the shortest path. So by sort of using advantage of the BGP protocol, it created what it called Anycast, which is not necessarily a product, it's more like a method where you are advertising the same IP address on multiple locations, and then the routers between themselves figure out, okay, to get to 888, which route I will take, and that might be completely different infrastructure in place. So you end up, in reality, having so many 888 addresses in the world, where most of the cases we thought always it's a unique IP address when we are trying to connect. So in that case, users in UK will end up connecting to that server. US servers will be mainly servicing the US customers. In this particular case, router will recognize that it's a shortest path to go the server in UK, and in that case, it will connect to the server above. This reduces latency and provides also the level of load balancing. In the case if that server gets offline, the routers will be already aware of the second path, which will be destination US. And again, it will be completely transparent from which really server that response came. And that's one of the big advantages with public DNS servers. There are multiple locations where same IP address will be propagated. And interestingly is that no matter where in the world you can access that IP, it makes DNS much more reliable, as well as 100% uptime, because if you shut down one data center for any upgrades or maintenance, the others will start servicing customers. It also improves the DNS performance because, again, it's a less hops to get to the answer. And more importantly, when it comes to the denial of service attacks, if there is a targets when it comes to DNS, there is several denial of service attacks method, then end up being either divided between the multiple location or segregated in one zone, which will be easier to fight without affecting other customers. So there is advantage there. And then adding scalability, kind of simplify, just add another orange dot, but literally once you see that in certain area there is a way more volume and more customers connecting to it, adding another DNS server using the Anycast protocol divides that load, and then you can really scale much better. So when we look at the public DNS servers, we mentioned Google, but there is many others. And one of the provider is called OpenDNS. They introduced also a free DNS service. You can use their IP address, and they use also Anycast to provide that service. But what they added on top of it is classification of the internet addresses. So each response or each query is sort of mapped to the 50 categories that are suggested by the users. So everybody can submit suggestions, say this domain should belong to this category, and then community will approve or not that belongs to that category. But in a way, they classified, and over 90% of requests that are going to the OpenDNS are already classified within the groups. So what advantage do you have with this feature? If you register your domain, your account, and you add a network being the IP address of your router, but a public IP address of your router, you can then define which categories you would like to block. So you have a list of categories, and you can decide what kind of or type of addresses you can block. And you can also add custom whitelist or blacklist certain domains that might not be in specific categories, or you want to exclude them from generic classification. In this particular case, the way it works, that as your user requests the domain name, the OpenDNS server will recognize the IP address from where request is coming, and then based on the classification, it will decide will it block or allow that access. Block, actually, it's maybe not the right word. It's not really blocking access to IP. What it does is actually provides the misleading IP address back to the user. It provides the IP address of the different web server that said that domain is not allowed by your administrator, and you can even post a comment that said, no, I really need to access Facebook or whatever. So in this case, you can get information and build that and change that. So it's a very simple way to kind of create that filtering, although it's not, as I mentioned, providing a firewall. So if user knows how to get to, they will still be able to get to that IP address. The question is, will it be able to really get a service? Now, on the right side, I have another screenshot, which is additional statistics that you don't really get with DNS servers from your ISP or from your, from your local DNS servers. It's a statistics information. What are the top domains? What are the IP addresses that usually users are connecting? Gives nice analytics, but also it's able to recognize certain IP addresses that are associated to malwares or some other website that are classified as a security risk. And when you see, when suddenly you have a malware installed locally that end up requesting certain website, OpenDNS can recognize and inform you and said you most likely have a security breach within your network. They're looking now into more but advanced methods by sort of using a pattern recognition and get more information about security. But that's definitely another value add when it comes to administration. Now, how we use the OpenDNS with the MikroTik. There is two ways that you can configure OpenDNS. The one is that where you use the MikroTik as a DNS server, and the other one where you just provide a redirect to OpenDNS directly. When you look at a first example, we're installing DNS server on the router, redirecting users to use the local IP address, and then MikroTik will end up caching information received from OpenDNS. Now, there's an advantage, disadvantage. Advantage is that you get response much faster, but if you're making any changes on the OpenDNS, you need to wait until that record expires. Every information, like at www.macrotick.com, will come in with what we call TTL, or time to live information. It's a time how long that IP address will be remembered locally. So if you end up deciding to block the domain, it won't be sort of propagated right away until that expiration kicks in, gets the request from the OpenDNS, and then basically get information that should be blocked or not. There is advantages in kind of how fast you can administer, but advantages that you get response right away because, again, it's within the LAN. Now, what is important is not to just provide IP address of the DNS server to the users, because if the user decides to change DNS and end up using, let's say, 808.808.8, you have to create a rule on your firewall to block the port 53 and not allow them to access the other DNS servers that has no filter in place. That's the example of the rules that needs to be added. Now, these commands that I just included here are, there's a few more that needs to be added. You need to put a firewall protection on the DNS, not allowed access from the public internet. You also need on the DHCP server to define the pool and the DHCP network, but I wanted to highlight the most important the commands. So in the first, on the left side, where DNS server is using the OpenDNS IP addresses, it's basically forwarding any request that is not locally found to 2867.222.222 address, and forcing redirect for port 53 to local DNS, where on the right side, the router is just providing the DNS service directly from OpenDNS. Then every request will be sent from the user to OpenDNS server, and we also have a rule to intercept any other ports and redirect to OpenDNS. When we look at how that works, as I mentioned earlier, it's all based on the IP address from where you're coming. So when you have not a static public IP address, but your IP address ends up being changed, then suddenly all these rules that you set up will not be anymore applicable, because OpenDNS will not recognize the IP address if it's coming from a different than what you originally set up. So how this is resolved is, again, using the two different ways. OpenDNS has a client applications that can be installed on Mac or Windows that will end up checking and recognizing if the static or public IP address is changed, and then using OpenDNS API to inform that that IP is changed. Now, obviously, you would need to have a workstation server running with a client, but there is a second method, which is using a MikroTik script. It's recently developed actually by OpenDNS, and there's a version of the script. You can recognize, the router can run the script being scheduled and recognize if the public IP address changed. And then again, from the script, contact the API and get information back to OpenDNS, what is the new IP address. So I provided a link. The script is quite long. It wouldn't fit the slide, but I'll post in the slides as well, or if you want to take a picture, you can go online and copy-paste that script and test it out. So what are the advantages and disadvantages? When we look at a public DNS service, so clearly web filter is the big advantage that you cannot easily achieve locally with the existing firewall rules. It's simple to use. It's a cloud-based, so no local hardware software installed. I mean, there is many web filter applications out there that you can install locally on the server, and WebTitan and some other type of applications that provide the similar functionalities. But again, there's a cost of the hardware, software, maintaining that. This is easy from the point that it's cloud-based and very easy to sign up. Additional data analytics and statistics are provided. And then security component is also a great value add. But in general, what public DNS providers provide with the Anycast is that reliability and redundancy. And that's yet another big value because, again, without DNS, we won't be able to access internet. Limitation. So you must get a public IP address from your ISP. Now, as there's a shortage of IPv4, we see more and more a private IP address assigned to the end users. When you have a scenario where it's a sort of a double net, when you have another netting in the data center, then suddenly you can have a multiple clients under the same public IP address, which is the problem, and that's where currently OpenDNS has no really viable solution how to do this, unless it goes through using some kind of a tunnels to create a unique IP address for that particular network. The content, it's interesting how they started. They started with the advertising, and they've been in the beginning using the sort of proxying content, injecting some ads, but a few years back they stopped with the advertising, and but I would say that there are still ability to use the proxy as a feature that you can enable or disable. But when we look at the functionality right now, if you just leave it by default, it will be responding exactly what the real IP addresses are. The third big challenge is the filter is all based on one network, meaning your office. If you have an office or household and you would like to apply the different rules, they're all seen as a one IP address. What you could do with a few rules that are not added here, but it can be easily configured on a MikroTik, you can create a special rule for specific IP addresses and say that for these IPs don't apply OpenDNS, but the rest yes. So you almost have filter on and off type of a feature, but not really granular settings per user. So in the case you have a business, you would like to divide different rules per department or group of users, that's not possible. And then the second mostly asked feature is ability to schedule use. And that's really coming more from the parental control, or also some businesses you would like to limit certain, not just the type of device, but also when they can access and for how long. So when we look at the last two functionalities, the way that OpenDNS try to address this is through integration with a Netgear. They introduced a feature called Genie that is more tailored as a parental control functionality. And the reasons why I brought up is not to promote the Netgear, but more to present that there is an option to integrate using the API. And currently, there is no solution for MikroTik, but we're hoping to introduce something in the near future. But the concept is simple. Routers are aware of your local LAN. They're aware of the IP addresses of your local users. And that's where you could actually solve that problem by being aware of the LAN. And being a cloud provider, they don't really know what's going on internally. And that's another value add that router providers could introduce. Now, interestingly, what and how this relationship with the Netgear will evolve, it's to be seen. OpenDNS was recently acquired by Cisco, $600-something million acquisition. So the question is how Cisco will play with other partners, other competitors, or not. For now, it's open, and OpenDNS is still its own brand. But clearly, there is thinking to integrate deeply with some of the Cisco devices. So we'll see. But that's pretty much it for today's presentation. Thank you, and I'm happy to answer some questions.
Thank you, Jovan. Do we have any questions? Yes. We're a community WISP, and we actually do double datting. And for liability reasons, because I was going to go to jail for all the peer-to-peer stuff people were stealing, we actually use OpenDNS to block peer-to-peer sites. Amazing. So if you're doing a double NAT and you're getting those letters that, hey, somebody's stealing something on the internet, we're going to send you to the jail, this is a great way to do that. When I first implemented it, we also use it for ad-aware. We block all the ad-aware stuff that people don't know about. The records on the ad-aware is amazing of the things could get downloaded that people have no idea. When we first implemented it, just for fun, I blocked the adult content 2 hours before I got my first phone call.
Of course.
Why can't I get to this website? I don't know. Let me look into that. So it's a good tool.
Thank you.
Thank you. Do we have any more questions? Yes, upstairs.
How does it affect the HTTPS if you're routing it through a proxy?
So they are not proxying. Obviously, they won't handle HTTPS, but if you enable the proxy, then you'll have a problem with HTTPS. Now, from the, as I said, by default, it's not proxying. It's just, giving you the IP address of directly the users.
Thank you. Any more? Thank you, Jovan.
Thank you very much.